In this lesson, we are going to look at the third section of Chapter 1, that is, the joint cumulative distribution function. Definition 1.3. Joint cumulative distribution function, or JCDF, of two random variables x and y is defined as the probability that the random variable x having values less than or equal to x and random variable y having values less than or equal to y. For the discrete case, this probability can be calculated using the double summation, and for the continuous case, it can be obtained using the double integration. Let's go back to the example 1.1. If we want to find the joint CDF, that is the uppercase F of 1, 2, that means the probability that the random variable x having values less than or equal to 1 and random variable y having values less than or equal to 2. This condition will be satisfied for the cells 1, 1 and 1, 2. Adding this probability, we can obtain 8 over 18. Now let's look at a continuous case. Going back to example 1.2, let's find the joint CDF of x and y. In order to find that, we divide the sample space into 5 regions. Region 1 contains values y less than 0 and x less than 0. And the region 5 contains all the values x greater than 1 and y greater than 1. The region 2 is where x having values in between 0 and 1 and same for y. And you can define R3 and R4 also. In region 1, both x and y are 0, hence the joint probability is 0. In region 5, both x and y are greater than 1, hence have attained the total probability 1. Therefore, let's calculate the probabilities for region 2, 3 and 4. Let's start with region 2, where x can have values in between 0 and 1 and y can have values in between 0 and 1. When we do the integration, we end up with the probability x square times y square. When we do the integration, we always do integration inside out, that is integration y from 0 to y first and then integrating x from 0 to x. Now let's go to the third region, where y can have values from 0 to 1 and x contain values greater than 1. Since x has values greater than 1, that means beyond the upper limit, we integrate from 0 to that upper limit, that is x from 0 to 1, while we integrate y from 0 to y. After performing the integration, we can get the answer y square. For the fourth region, we follow same now with x from 0 to 1 and y greater than 1. Again, since y contains values greater than 1, that means beyond its limit, we integrate y from 0 to its upper limit, that is from y goes from 0 to 1, and then we integrate x from 0 to x. After that integration, we end up with the answer x square. Now let's put all the regions into a 1. Since we already know for region 5, the total probability has obtained for both variables, therefore, the probability where x from 0 to 1 and y from 0 to 1 will be the total probability 1. Hence, the joint CDF can be written as this equation. Remember, for the CDF, we always use the uppercase letter F. For two continuous random variables, we can use the joint CDF, that is uppercase fxy, to calculate the joint PDF. That can be done by doing the partial differentiation with respect to x and y. Here's an example. The joint CDF of the two random variables is given as the following function. Here again, x contains value up to 1 and y contains values up to 1. Now let's find the joint PDF by doing the partial differentiation. Let's first take the derivative with respect to y, considering x as a constant. And then we apply the derivation with respect to x, and we end up with the joint PDF 2x plus 2y minus 2x 2y. Let's write the answer in a proper way as follows. If you want to check whether this answer is correct, you can always check it using the condition 3. If you integrate this joint PDF, x from 0 to 1 and y from 0 to 1, you should obtain 1, which is the total probability.